Good evening, everyone, and welcome to the November meeting of the Society of Motion Picture and Television Engineers, better known as SMPTE, for New England. I'm Marty Feldman. I'm the section chair, and I would say tonight is a very special evening because our guest speaker tonight is HUGO Gaggioni. And if you're in this industry and you don't know HUGO Gaggioni, you're going to know him after tonight. He's the Chief Technology Officer for Sony Imaging Products and Solutions of the Americas. And he's going to be showing us some of the latest technologies that Sony exhibited at the IBC show in Amsterdam recently. It was a couple of weeks ago. And it'll boggle your mind. It's they always, whether it's NAB or IBC, they always show some new things, new technologies, and new products. And I think you're really going to enjoy it this evening. And I hope you'll come back and watch it again on video on demand. And of course, we have a studio audience here. But I think we probably have more people at home. And that seems to be the way a lot of people are watching these things today. So we hope you'll sit back, get comfortable, and enjoy listening to HUGO Gaggioni. HUGO, it's all yours.
Thank you, Marty. Again, good afternoon, good evening to everyone on this presentation. And I have lots of slides, a lot of topics I want to communicate to you of what we presented at this IBC show in Amsterdam. And if you have questions at the end of this presentation, please convey them to the conference, and I'll try to answer them as best as I can. Okay, we launched about 3 years ago something we call the Media Solution Palette. Is a ecosystem where we mix cloud and on-prem environments to be able to carry applications and signals all the way from acquisition to the other extreme of the viewing that we have in our homes. Our purpose is to be able to achieve very high quality live production, and the key here is the word live, real time. With no delays, with ultra latency responsiveness of the actions, and to achieve the best that each one of these environments can offer, whether it's the cloud or is on-prem. And to achieve this, we have to develop a number of technologies to interconnect these two environments. In the particular platform of the cloud, we call it the Creators Cloud. Once again, launched about 2 years ago, we created a number of applications which we consider as gateways to bring the signals that are generated in the field into this environment we call the cloud. And the picture quality has to be very, very high. It cannot sustain any degradations, whether it's HD, 1080p, 4K. We have to transmit them at very high speed into the cloud. We have to integrate workflows that different people may have in the field. It can be distributed production. It can be remote integration from the stadiums to broadcast centers. All of them have to be accommodated in a very efficient way. And to do that, we created these applications that I'm going to call them now. One is the C3P, Camera Cloud Connect Portal, and I'll explain that in details in a minute. We also have M2L, multi-point to multi-point live software switcher. It's a video switcher in the cloud. A2P, AI automated production, the use of artificial intelligence to accelerate the creation of metadata for highlights for sports applications. C is our media cloud that Sony has been using for a number of years. It's our repository for collaboration and archiving and transcoding of the material that we bring from the field. And Navigator X is our media asset management, a media orchestrator that we've now deployed in a number of broadcasting centers. Let me begin very briefly on the A2P, AI automated production. We began experimenting with this application about 5 years ago in order to help analyze video stream for sports applications, in order to identify different scenes, different events, which allows us to create very rapid edits and selection of segments to create the highlights for halftime, for example. And this A2P is now a complete product. It's being offered as a software as a service product. And we showed it last year. We exploited even further at NAB, and we show some new features during this IBC. Essentially, we receive signals, video signals, whether via SDI or IP. We have what we call a rule engine, an artificial intelligence rule engine that you train. You actually teach this engine to identify what you want in the identification of the clip, whether out of bounds or a movement by different people, a skeletal recognition of the referees. You train these algorithms to identify those scenes as the video comes along. This identification helps in the tagging of those segments, to help in the editing of the segment for final production of the highlights. We have a number of AI engines that we have perfected through the years. For example, we have emotion detection, eye recognition, a smile, skeletal recognition, character recognition, ball tracking, player tracking. All of these engines begin to work in parallel in order to identify all the elements that you have in your video. But you have to teach the algorithms to recognize what you want depending on the sporting event, whether it's baseball, football, tennis. Once these tags are created, are automatically created, but it can also interact with manual tagging. Therefore, a technical director or a supervisor can override the decisions of the algorithms and create the editing point for the highlights. Therefore, it's a combination of machine learning as well as manual integration by the editor. The C3P, Camera Connect Cloud Portal, is our gateway for connection of our acquisition cameras to the cloud. Essentially, it's a very easy way to use your phones to be able to scan QR codes that are in the cameras. These are Sony cameras, but just simply connecting to the QR code, this establishes a connection between the camera to the cloud system that we have, which is C. And this we call a C3 portal. Is an application in your phone. Allows to establish a very secure and stable connection that you can use to transmit a streaming or the files that you have recorded in your cameras. You can do faster than real-time transmission by doing chunk and file transfers. And recently we are adding also AI tools to do speech-to-text conversion, so that the voice that you're recording can be converted to text, so that you can do a search by metadata of the text when you receive it in your newsroom computer system, for example. Then graphically, here you have your cameras, whether they're HD or 4K in a news gathering application, communicating with the portal, and allows you to completely connect the cameras to the portal. You can even manipulate the cameras, set up the cameras automatically from the portal. You don't have to have a human operating the camera. As you will see, the production center or the newsroom computer environment can be operating the cameras remotely through this portal. Once you determine what pieces of the recording you want to transfer to the production center, you can use SRT, RTMP, a number of transmission protocols with very low latency to transmit that video into the production center or to your final storage or archiving location. This has been maturing and perfection during the last few years. Recently, there's a number of companies that have been using it for connection into our C Media Cloud. C has now probably over 200,000 users around the world, with over about 30 petabytes of storage. It's an environment for collaboration, for archiving, for transcoding. It's a number of tools that reside inside this cloud. Sony owns rents this storage from AWS, and we actually resell the applications along with the storage to the end users. All of our cameras now practically are now able to communicate using QR through the portal. Only the most recent cameras, which are prosumers or even consumer cameras, sometimes require Bluetooth for communication to the cloud. But we are trying to apply the QR connection because it's the easiest way and fastest way to communicate with the portal. An application that was originally created in Europe and now is beginning to be employed here in the US is not only camera to cloud, but actually camera to newsroom computer editing system. And this is, we are using Avid and the Avid Media Composer and the Avid News, iNews, to create the metadata corresponding to the rundown of the news. That metadata is sent to the cameras, the camerographer photograph the segments of the news, and using the Sony portal and an application called Marquise that allows us to segment either the files or the streams and transcode or rewrap the files to be able to be processed by Avid Media Composer. Then very efficiently from the camera all the way to the editing platform is now, we can achieve that functionality using the C3 portal. Okay, coming back to this environment of the cloud and on-prem, now I'm going to transition to something called Network Live. Network Live is the series of technologies that we have to develop to join the cloud processing capabilities with the on-prem capabilities. And to do that, we needed to have a network and media orchestration, as well as network orchestration, connectivity between LAN and WAN, and very fast transmission technology. We had to develop a new compression system to be able to reach the cloud or the on-prem at very high speed, with very high picture quality and low data rate, which it was a significant challenge. Also, listening very carefully to the demands of the marketplace, we recognized that not always people wanted everything just being processed in the cloud, but most people wanted a hybrid environment where they could share the resources that we have in the cloud as well as on the on-prem, the equipment that they already own in their broadcast production centers. Then again, expanding a little bit for you to be able to read, we had to develop a new technology also for distributed and what we call stackable processors. Therefore, rather than just simply remote integration, we have now the capability to do a distributed production, where some of the elements of the production reside completely in a different geographical location. To achieve this LAN WAN connectivity and to migrate more into the world of telecommunication, Sony acquired a company called Nebium about 3 years ago. Nebium now is a full subsidiary of Sony, and they are really super expert in the area of telecommunication and networking. And they've had a very extensive track record of installations around the world that complements our knowledge and products that we have in our implementation of IP in Sony products. Originally, the idea was to be able to try to bring as much as possible the processing that resided in remote locations into a hub, into a centralized location. And to do that, we needed telecommunication lines, WAN connectivity. Yes, that was one of the premises, but more recently, we are now moving more into distributed production, where we are not bringing all of the elements for a centralized production, but the production can take place in multiple places and simply being unified in a centralized location. And I'm going to show you some of that technology in a minute. This environment, this end-to-end environment, is controlled by a number of software layers, in particular one called the Video iPath. Video iPath is a product from Nebion, originally a network orchestrator based on software-defined network control technology, but now it has become more of a broadcast controller as well as a media and resource orchestration that connects and communicates with everything that you have in the network. All of our products that Sony makes have now an IP interface complying to the SMPTE-2110 standard, whether it's 10 gigabit, 25 gigabit, or 100 gigabit transceivers in the back of our product. And all of them are fully compliant to the standards stipulated by 2110, by ANWA, by NMOS, and the Joint Task Force on Network Media. Okay, the two products that we have inherited from Nebion that allows for this transition into the world of telecommunication is one is the Video iPath, the Nebion Video iPath, which is our media orchestration platform, and the other one is called Virtuoso. It's a software-defined media node for adaptation of the LAN environment to the WAN environment, and I'll tell you more in a minute. Video iPath, again, is an orchestration platform with the responsibilities of controlling the workflow for the broadcast, controlling in a broadcast plan, as well as the network environment and monitoring of all the activities that happen both in the production center and in the network. Therefore, there you see, it can be used in SDI environments, in IP environment. It has full responsibility to assign the bandwidth of the network, depending on whether you are working in high definition or in 4K. It supports IP switches from multiple vendors. It's not dedicated to a single vendor. And once again, fully compliant with the NMOS dedicated drivers. And recently we added the broadcast control features that you see here. For example, control of the switching matrix that we have for the video switchers, stylists, alias naming, grouping for audio and video. Manual control panels can also be controlled by Video iPath. At IBC, we were showing, it's not a finished product, but one of the most difficult things for an IP installation is to mimic the versatility of an SDI switching environment. For example, the RCPs, the remote control panels that we have in cameras, communicating to the cameras. Well, we achieve that responsiveness of controlling cameras through the RCPs totally in IP by allowing the RCPs to communicate with Video iPath. The Video iPath is monitoring all of the actions that you have in your remote control panels of the camera, studio camera, and Video iPath can control the routers in the environment. And that was very well received at IBC. The other technology, very unique to Video iPath, is called Federation. Federation is the name that we're using to define the connection of multiple autonomous entities or video iPath systems. Each one of the video iPaths may be processing a specific location or a truck or a studio, but they are all communicating with themselves. They have full knowledge of what the other video iPaths are doing. Then in case there is a network failure or a system failure of another video iPath, the other video iPads can take over and complement those functions. This is called federation. The Virtuoso, as I said, is a software-defined media node, and the name Virtuoso because it has a lot of capabilities. In terms of video transport, can transmit, of course, uncompressed video, JPEG 2000, JPEG XS. I'll show you a new algorithm that will be incorporated into Virtuoso in a few months. It has video processing in terms of up and down conversion. It can do a high dynamic range, look up tables for conversion between SDR and HDR. It has transport stream communication between the ground and cloud over LAN and WANs. Therefore, it's a very versatile a production unit, processing unit that sits at the boundary between the local environment and the WAN or intercity environment. Hence, it has a middle layer, which is an operating system, driving a number of hardware accelerators. These hardware accelerators can be purchased at different speeds and capacities, and you simply load different functionalities, different applications on that processor. The vision that we have for a Virtuoso in the very near future, we will evolve to support NDI via an SDK, and also the support of SRT. Right now, it's not quite ready to support SRT for communication. Okay, in the area of hybrid processing, again, trying to reach this dream of distributed production and using cloud agnostic as well, we began exploring the idea of a new architecture of video switching. Of course, we are well known for a very strong family of video switchers, but these were very monolithic. Therefore, all of them are IP-based with capabilities up to 100 gigabit per second. But you were sitting in front of a chassis, a processor that at most could be deployed as two logical switchers. You could use the power of computation of one chassis across two studios, but you could not physically disassemble the chassis and put part of that chassis in a stadium and the other part in another location. Then we at Sony designed this new architecture, which we call is an scalable IP switcher for live application, the MLS X1. And it's a processor, very powerful, that is based on three technologies, CPU for system control, GPU for basically graphic processing, and FPGA for real-time processing at very high speed. And fully 2110 compliant and capable in HD up to 8 MEs in single box, in UHD up to 4 MEs. And originally, last year, and even at this NAB, the connection of these modules was all around 100 gigabit cabling into a cross-point box. Okay? But at IBC, we introduced cards that allows SDI connectivity. Therefore, these modules, with all the power they have, can be used both in IP as well as in ADI for those organizations or studios that are not fully upgraded to IP. Then you can grow the power of computation from a single box to an incredibly gigantic video switcher, and using 144 inputs in 4K. And these boxes can be deployed in different locations. You can add or subtract boxes depending on the requirements of your application. And these boxes become logical switchers that can operate in 4K or HD in different configurations depending on what your application calls for. In particular, the notion of having these boxes deployed to the stadiums, do pre-switching, pre-processing of the video at the location, and then use the communications to the cloud to bring that signal back to the broadcast center for completion of the program. Okay, that's hardware. But we've been asked for quite some time to produce a software-only video switcher. And about 2 years ago, we introduced something called M2 Live, M2L, multi-point to multi-point live. It's a very simple, but still powerful software switcher. It's a software that can operate in 4G, in Wi-Fi, in 5G, and we aiming at a second tier, third tier type of a sports application, very simple, maximum 6 channels of video. Every channel of video has 6 channels of audio, very easy to use. You only need a computer and the cameras to create your production. But once again, the aim was only for reduced complexity of production. Then you couldn't use this for the production of an Olympics. It would be too complex, and the requirements would be much more complex to address. And based on this architecture, by the way, this is how we have been selling it and using it. We can transmit SRT programs, quality of service streams from Sony cameras, HEVC streams. And this software also uses the AI tools of A2P in order to help create that metadata to facilitate the editing. And once you produce your program, you can transmit that program to social media and YouTube or any other, even over-the-air programming. But again, we were not tackling perfectly the requirements of very top-tier sporting applications. Then at NAB and further more mature at IBC, we introduced something called M12X. It's a fully blown cloud-based video switcher that it will communicate in a hybrid mode with on-prem switching. And as you can see here, depending on the complexity of your sporting event, sometimes a software-only very simple switcher is enough. Sometimes you have to add additional hardware and more complexity to satisfy major sporting events. Then M12X is now in combination with the scalable switcher, so that a single control physical panel that the operators are familiar with can operate simultaneously resources that reside in the cloud or on-prem, and the operator doesn't need to know where they are. Okay. Then we have been doing quite a good number of POCs with broadcasting companies that have significant sporting requirements. This software can handle up to 24 inputs, and each video input can support up to 16 channels of audio. That was very important requirement. We're capable of supporting SRT, NDI, RTMPs, and also connections, interfaces for third-party services that I'm going to show you in a minute. Therefore, this software can be used as a primary production software where everything is done in that software and you end up with the host feed completely produced, or it can produce a secondary production where you receive the host feed from the event and you complete the production using additional elements that you may have in the broadcast center. And this is a graphic of a typical POC. Essentially, we have the equipment that the broadcaster owns. We've been doing this with the MLS X1, the stackable switcher. We have this M12X is now being productized using AWS platform. And we have a number of additional vendors. We have Chiron, Waves for audio processing, TAG for the multi-viewers. And again, the operator is handling facing a video switcher. But this video switcher have MEs and segment corresponding to elements that may reside on-prem or in the cloud. And the interesting thing is, well, what happens if I have to do a switching or a fading or a cross swipe between an element that is miles away in another country and an element that sits on-prem? And we've been polishing this very well, and in order to that the latency minimized to the milliseconds in order to produce very clean effects irrespective of where the cloud production takes place. This is the version 1.0 of the software. It's now operating only in 1080p, 50 hertz to 60 hertz, and 24 input, SRT, NDIs, Sony quality of services. I'll tell you what Q of S means later on. 12 layers of chroma key. Well, you can read the rest. And officially, as a product, is released in spring of next year, but it's now being tested very thoroughly in advance of some major sporting events next year. Okay, another element in this communication. How we bring these cameras to the cloud or to on-prem very rapidly with ultra low latency. Well, we have developed something we call ULL HEVC transport. This is the situation that we have many locations, whether they are cloud, broadcast centers, studios, trucks, and the cost of bandwidth is enormous. 4K, you know very well, is 10 gigabit per second payload. 1080p is 360 megabit per payload or more. Then that is very difficult to afford, let alone find that capacity provided by telco suppliers. Then we have identified a channel bandwidth of 1 gigabit per second that is affordable and very ubiquitous. Many telco suppliers can provide that bandwidth. And we are aiming at sending over 10 cameras in 4K over 1 gigabit per second, or over 30 cameras in HD 1080p over 1 gigabit. Well, if you do the math, you realize that this is very crazy levels of compression ratios to achieve. And there are three things that are always fighting each other: quality, data rates, and latency. And until recently, you can only have two at a time. You could not have three. Okay? Then we have developed this as a chip. We call it an ultra low latency HEVC, corresponding to the H.265 algorithm, but with very unique architecture in encoding. Of course, we produce a compliant stream that complies with the H.265 standard, but this unique encoding allows us to have extreme levels of picture quality with less than 2 frames of latency, less than 30 milliseconds. And at data rates, for example, we are now recommending a 4K data rate between 60 and 100 megabits for 4K, or 18 to 35 megabits per second for 1080p. Then we've done a lot of demonstrations and the different shows, but here is a picture comparing the picture quality of this ultra low latency HEVC against baseband in 4K or in JPEG XS. To get a decent picture in JPEG XS, you're looking at data rates of 2 gigabit per second, 1.2 gigabit per second. We can achieve those levels of picture quality at 100 megabits, 60 megabits per second, which are factors of 200 to 1 compression ratio. Okay, then those chips, a single chip will handle 1 4K or 4 HDs in 1080p. We are going to deploy this technology in a number of products, and the first one is the ME80, NXL ME80. We call it the LAN 1 gateway. I'll talk about it in a minute. The other one, the RPU7, is a wireless remote production that connects to cameras. And in the very near future, that algorithm will also be embedded in the Virtuoso product that I talked about earlier. This is it's a media edge processor, the ME80. It has 2 chips inside, and therefore it can handle 2 4Ks or 8 1080ps. and it can support ultra-low levels of latency, or for certain transport, we can also do a non-ultra-low latency operation. And fully compliant with 2110 if you're bringing your signals in IP, or with the SDI 12G if you bring them in over SDI. Then the signals coming in, it has an SFP 28 if you bring them over 2110 IP, but the connection between using WAN connectivity is an SFP plus connector, which is 10 gigabits. Over that link, we have a special protocol of transmission we call Sony QoS that works in conjunction with the encoding to achieve this ultra-low latency that I've been referring to. The recommended data rate, once again, 60 to 100 megabits for 4K. Maybe we can dial it up to 200, but it's an overkill. I think even 60 megabits is very high quality. HD, between 18 and 35 megabits per second. And once again, compliant to, it can be controlled over a web UI, or the video iPads can control this over a network orchestration. You can send 4 signals one way, receive the other 4 signals the other way. You can achieve a 4-time high frame rate, super slow motion, sending the 4 faces of a camera over 4 faces of 1080p. Then what we are positioning this product is basically for a sports application, for remote operation, where you want to transmit a number of cameras from a venue to a production center. These boxes can be gen lock using a PTP. Therefore, you happen to have 32 cameras in a truck. Well, you have 4 of these boxes, you put your PTP over the IP connection, and these 4 streams are fully synchronized with timestamps. Okay? The same chip, one of them is now also placed inside a remote production unit we call the CBK RPU7, which is an encoder that connects to shoulder mount cameras or handy cameras. It works with 1 channel of UHD or 1 channel of HD. That's it. Okay, and there you see the examples. We are looking at target data rates for between 35 to 200 megabits per second in 4K, or 12 to 100 megabits per second in HD. The connector, the unit can be connected to a shoulder camera using a camera mount bracket, or a rod bracket for cinema cameras. Also, it can be used in a shoulder case type of mount, so that you can have a handy camera connected. The connection between the camera and the unit is using just a BNC cable. Okay, you have 12G or 3G, you connect into the unit, but the output of the camera is either RJ45 or USB-C. USB-C. Therefore, how do I go into wireless transmission? Well, we connect the USB-C output into a 5G gateway, which happens to be a phone. We have our Xperia phones, and the phone becomes your gateway into 5G. Okay, and there have been many examples of this. The coronation of King Charles was one of the early ones, all communicating over a private 5G network. Okay, the goal for transmission of bringing this into a sport application is the encoding and decoding has to be very fast, because you can picture the process. You have your wire cameras from the stadium to the truck, and you have your operators, your field camera people in the field. We can afford to have maximum 150 milliseconds of latency, point to point, in order to match the handheld cameras with the wire cameras. Therefore, subtract 30 milliseconds of encoding and decoding, and it's doable. It's manageable to achieve that type of a latency. Here you see it. Okay. Also, the software switchers that I've been talking about receive the Sony QoS, which can be transmitted from the camera directly into the cloud. Today, there was a press release, and I just decided to place this. This was a POC that took place in Denmark, in Copenhagen, just a few days ago, of a full production in one of the TV2 in Denmark, using a combination of companies, Sony, Nebion, and also as a private 5G environment. Okay? Very important is the notion of bandwidth orchestration. This is very important because usually a 5G channel is around 140, 150 megabits per second. If you go into a public network, everybody's gonna go into that network. And if you have your camera, people are gonna start stealing bits from your bandwidth, and you're going to start dropping frames. And we have developed a priority algorithm, prioritization algorithm that protects that bandwidth, and we have been using it in private networks. Therefore, in 140 megabits, you can put 4 cameras if you assign about 35 megabits per second per camera, or you can put 8 cameras, 35 megabits for the priority one, 18 megabits for the other guys, and depending on who you select for transmission, you can assign the bandwidth on the fly. Okay, it's a different topic. Some new announcement on the camera, system camera portfolio. As you know, we have a very rich portfolio of cameras using 230-inch sensors in HD, in 1080p, in 4K, all the way to 8K, and with global shutter. And about a year and a half, 2 years ago, we introduced a single sensor, 230-inch, for cinematic acquisition. This year, we introduced the 3500V and the 5000V is essentially the older cameras with a number of new processing features, specifically 4K at 4 times super slow motion that had not been achieved before, and a continuously variable neutral density filter. Okay, let me explain that. Well, here you see these new features. The 4K times 4 capturing, specifically for the 5500. The new variable neutral density filter applicable to all of the Sony cameras. We have a new camera. It's an entry-level 4K camera that is upgradable from HD by a license. And also we have a control network system that allows us to control cameras in multiple cities and multiple countries. Okay? Let me just go quickly on this. Electronic variable neutral density filter. Okay, this is a mechanical structure with multiple glasses that sit in front of the sensor of the camera. It can be applied to the 3500, 5500, the P50, and also purchased as an accessory for cameras that were purchased in advance. One of the issues with the neutral density filter is that so far there has always been about 4 or 5 positions, clear, 1/64, 1/16, and that neutral density selection can only take place when the camera is not on air. You cannot select it when your tally is on. And in the issue is sometimes you want to achieve a shallow depth of field, which you will do by closing, by opening the iris, but then you have to fight the illumination. Or you want a deep depth of field by closing the iris, but then you don't have light. Then these type of things were really very difficult to control in live production. Then this a continuously variable ND filter, it has about 7 stops of continuously variable from 1/3 to 1/256, continuously changing, opposite to the aperture of the iris. Therefore, as you close the iris, the ND filter becomes more transparent. As you open the iris, the ND filter becomes darker. And they're in perfect synchronism. And the operator, in order to help the operator manage this, then in the RCPs is a very simple graphical interface where you simply set the sweet spot of the lens. Usually it's between 2.8 and 5.6. If you go more, you will have some lens artifacts. Then you select, let's say 4.0, f4.0 in the lens, and you adapt the capture by using the gain of the camera and the ND filter by just moving a single joystick. And the system automatically will engage the ND filter. Very, very interesting technology that allows you on the fly to do artistic intent, very shallow depth of field or very deep depth of field without having to worry about illumination. The other technology was a very high speed in 4K. We've been able to do 8K, 8 times high frame rate in HD, or 6 times high frame rate in HD. But in 4K, we have only been able to do so far 2 times. The camera head, the HTC 5500, was able to reach 4 times in 4K, but the CCU didn't have enough power, signal processing. Then we introduced a signal processing card that allows this card to produce essentially 240 frames per second in 4K for super slow motion. Okay. Why do we want that? Let me see if it is here. Well, especially in Europe, but it's now becoming more, it's available here, the LED walls that surround the stadiums have multiple advertisements. They corresponding to different countries. You have your Italian commercial, your Spanish commercial, your German commercial, and running the cameras in high frame rate, you sync one of the phases of capture to that commercial. Therefore, the feed for that country has the people playing with the advertising with the corresponding language to that country. That's fine, has been very successful, up to 6 times. High frame rate, but especially in Europe now they're moving into 4K, and they wanted 4 times in 4K for this type of application. The new camera, the FC90, is an entry-level, is a camera in HD, but the sensor is 4K. And it comes straight 1080p in HDR, SDR, but by just simply buying the license, the camera becomes a 4K camera, 12G connection directly from the camera head. It has very high oversampling to produce dramatic HD quality because the sensor is in 4K. It has the ARIA and the ALAC automatic correction for the lenses. It has also a magnification, 2 times and 4 times magnification with no damage of how to process the brightness of the scene. And of course, it supports HLG and S-Log3 for high dynamic range processing. Okay, that's a brand new camera. The other technology is what we call camera federation, is to be able to control a larger number of cameras beyond the 96 cameras that today we can control on a master setup unit. That was the limit we have so far. Now we can have a monitoring and graphic panel that can allows us to control and set up cameras irrespective of the area where you have those cameras. And essentially this. Ultimately, we would like to achieve this also with communication with the cloud. We are not there yet, but there you see the dashboards of the settings, behavior, monitoring of the camera in multiple cities. Extended in theory, we could achieve up to 960 cameras. Essentially, it's 10 domains at 96 cameras per domain. That would be the maximum number of cameras that we could control. Very quickly, augmented reality. Our 3500 and 5500 camera head have a gyroscopic device in the camera head that allows for to create metadata describing the positioning of the camera head, tilting, rotation, any lens information can also be communicated to the camera, and the camera, along with that chip, convey the metadata over the fiber cable. We had this for a number of years, and recently we've been cooperating with graphic engines such as the Unreal Engine in order to create control the graphics produced by the engine depending on the motion of the camera. Okay, it's virtual reality, as you can see there. Okay, there's an example. This is one of our labs in Japan. Of course, we don't have a Ferrari in the lab, but we could artificially create the graphics, and we can change on the fly as the camera zoom in and zoom out. But the sensor inside the camera doesn't compute, cannot detect the actual physical location of the camera in an environment. Then we've been cooperating with other vendors, specifically RaceLogic, which is an outside beacon or tracker that can be placed either in the pedestal of the camera or in the camera head. Then as you move the camera, the tracker communicates with beacons, reception beacons that can be placed on the ceiling or in the walls, then to have a notion of where that camera is physically in the environment, and then communicate to the graphic engine. Okay, important is this element of lens distortion, because if you want to create graphics based on the position of the camera, those graphics have to be believable, as if they were captured by a lens, but they didn't. They were created outside the lens. Then we have this capability of tracking the lens information as you zoom in, zoom out, and all of the defects of the lens can be communicated as metadata, so that the graphic engine distorts the graphics as if they were captured by a real lens. Okay, because if we were doing this without that pre-distortion, it will not be real, it will not be believable. Okay, well, with this technology, we had our major event at the Super Bowl this year. We've been working with the Fox Sports and these companies, Skycam and RaceLogic and Silver Spoon. We did a lot of trials and testing with Skycam in order to locate beacons around the stadium and calculate the distortion that traction of the camera over the trajectory of the motion, and to compute where in that motion the artificial elements were going to be placed. Okay, and I cannot show you the actual video because it's not public, but if you saw the Super Bowl, the game, you probably saw all these special effects that were floating around in the environment, following the actual tracking of the trackers in the camera, as well as the internal gyroscopic of the camera head. Okay, just to conclude, a few words on virtual production. At the IBC, we had 3 different classes of demonstrations, one on a special set of tools to help the virtual production in actual cinematography, employing the Venice 2 camera. We have another demonstrations of multi-camera switching for in-camera video effects. I will not discuss it because we don't have time. And the augmented reality demonstration we just discussed. At this show, we introduced a new camera called Burano. It's a very special camera, very small, very powerful. It has an 8.6K sensor, very similar in capabilities to the Venice, but Venice is more for a project, very large environment in production. This is for a single person. That it has recording capabilities of the XOCN, the light, it's PL mount, E mount. It has also HEVC, intra-frame compression for AK compression, in addition to H.264. It has in-body stabilization and a fast hybrid autofocusing using artificial intelligence, recognizing faces, eyes. It also employs a very fast memory, the BPG 400 Type B, to allow for this very high data rates produced by recording AK. The complement of acquisition is the LED wall, the CLED, and we introduced a new crystal LED for virtual production. One of the key issues now in LED walls is that when you're photographing a visual production, if the subject in front of the wall has black elements, they look black in your camera, but the walls are not presenting very deep levels of black, and there is this level of disparity between the graphics in the LED walls and the subject. Then this is a new type of CLED display that has very deep black and anti-reflection surface technology to produce really very low levels of blackness. It comes in a 1.5 millimeter and 2.3 millimeters spacing, and also these panels can be controlled by the controllers Brompton megapixels that are very popular, capable of reaching up to 1500 nits of brightness, and able to reach over 7,000, actually 7,680 hertz of refresh rate to eliminate any type of artifacts that moirette that may occur between the scanning and between the camera and the LED wall. Very low power consumption, very easy mechanical capabilities. You can have bending of the panels to achieve a semicircular type of walls, and very light in weight. The tools that we created to help virtual production, one specific problem that is encountered today is that specifically when you go with the Unreal Engine has a so-called virtual lens and virtual camera. Then the director of photography or the director of the movie creates certain colorimetry and settings of the camera based on those virtual tools. But when you take those settings and you go to the real on-set environment, you find that they don't match. And you spend 8 hours now recalculating the lenses and the cameras. Then what we've done, specifically for the Venice and the CLED wall, we have created a plugin, a virtual Venice plugin that you connects, is loaded into the Unreal Engine and allows the Unreal Engine to execute those tones and as if you had a real Venice camera feeding the Unreal Engine. Okay? And then once you get those settings, you drop them or load them into the controller of the CLED wall or in the Venice, and you're ready to go. Also, this environment, we have something we call a moirette detection algorithm, because sometimes you are moving the camera and you don't see in your video monitor that you have moirette. you have moire issues, but you're recording them. And when you get the material in post-production, you realize that shot, it doesn't work because it has moire defects. Therefore, we have an algorithm now that can detect different levels and will set up alarms to tell you don't place the camera in this position or in that position because you are about to enter a moire zone. Again, what I just said regarding the moire issues, the on-set production and setting of the cameras, just basically setting, once you calculate the settings of the camera, just load them into the Unreal Engine. And one more element that is very important is the calibration of the silhouette wall, because every wall, not necessarily Sony wall, but there are other vendors, have different spectral energy in the wall that will create different chromaticity specifications and reactions between the camera and the colors in the wall. Then we have a tool that allows us to calibrate that wall in advance, specifically for the silhouette, so that those parameters are now set in conjunction with the information of the camera. Those parameters can now be fed into the controller to alter the colorimetry of the wall to match the colors that you were expecting in the Unreal Engine. 3 more slides. An update on monitors. We introduced at NAB a 4,000 nits professional display. It's the new BBM HX3110, and the existing flagship was the HX310, now become we lowered the price. It's still in production, and it's a 1,000 nits display. But this new 3110 has some very unique specifications. It's not only 4,000 nits, but much wider viewing angle, and also very fast response, so that you can examine whether the blurriness that you see in the picture is due to the camera or is due to the panel. It has up to 30 memories for storage of 3D lookup tables for HDR to SDR conversion. It has 2110 interfaces. We can now come directly in IP into the monitor using the 22-7 hitless failover property. It has a JPEG XS decoder. These are all licenses that that are optional. The 2110 is a standard. The connectivity on 2110 comes with the monitor. Availability begins in January of the next year, and we've been doing some demonstrations of this panel. We introduced a small, very inexpensive LMD family of displays. It's an 18-inch with a very high brightness. Not 1,000 nits, but it has all of the EOTF for HDR to HDR production, but it's very inexpensive. It is very suitable for broadcasting trucks. And key among all this family of products is that all of them have perfect matching of the colorimetry points. Then whether you're buying the 4,000 nits, the 1,000 nits, or the small product, all of them match perfectly in terms of the coverage of the color gamut, and both also on the coverage of the DCI-P3. And what you see in the field is what you're going to get in the post-production environment. Well, with that, this is my end. Thank you very much for your attention. Any questions?
No demo to show,
Huh?
nothing to show. No toys to play with.
Okay, yes. I have some questions here, but okay. Any questions from the audience? Not nasty ones.
Facial recognition, how does it work with, say, ice hockey?
Say that again?
Facial recognition?
Yeah.
How does it work with ice hockey?
Because of the
Because
helmet.
they've got the helmet.
that's beyond my pay grade. Something very interesting that I noticed recently. Sometimes the cameras only focus on the eyes, and even if you turn your head, the camera is still in focus because the algorithm knows that those eyes belongs to a head that's rotating.
Follows the eye.
It's follow the eyes, whether you are facing or. In the case of ice hockey, will be recognizing a helmet or a number.
Okay, thanks.
So those licenses on the monitors there, are you giving up anything? For example, the fast response was a license I saw on the new monitor. Do you know yet if you're giving anything up if you have that license?
I'm not sure about that. I understand that. Could you?
Okay, the license, the monitors had a bunch of licenses that you get for
Yes.
different things. One of them was a fast response license. Are you giving up anything if you turn that function on?
No.
Okay.
No.
I mean, does it change?
Well, let me clarify this. We play high brightness against response.
Yeah.
Therefore, if you are at 60 hertz, you can have 4,000 nits, 2,000 nits. If you now move to 2,000 nits, you can have 120 hertz. Okay? If you have beyond that, you end up with 1,000 nits maximum. Therefore, it's much faster and brighter than the X300 monitor that we used to have in the past. That was the fastest. But right now, this is the fastest.
That was my expectation. I was wondering, does it work that way or what? Okay.
But once you buy the license, it doesn't disconnect the IP or the JPEG access or something like that. It's not conflicting to that. Okay. All right, let me. Okay, is Sony HEVC ULL proprietary? Is it compliant to the H.265 standard? Well, remember that in MPEG, and the MPEG committee was the one that designed the H.265, the important thing is compliance to the decoding stage. You have to create a stream that is perfectly in syntax and semantics registered to the standard that was produced by MPEG. You cannot deviate. But how you produce that stream is up to you. It's up to the vendor, up to the creator. Therefore, in the encoding side, we have a lot of latitude to create that architecture. And you know, you have I-frames, B-frames, P-frames, and the long-op capability usually is penalized by latency. But long-op gives you low data rates. Therefore, if you want high picture quality, low data rate, you have to pay the price of latency. Now, with this trick, very clever trick, we are able to reach under 2 frames of latency, almost as quick as an intra-frame compression, but maintaining the low data rate and the high picture. But it's fully compliant.
So to shorten the latency, more compression has typically been the answer. To shorten the latency, like I say, to go
No, if
from 500 milliseconds to down to 200.
if for a normal HEVC, if you shorten the COP, the group of picture, and let's say you go to iframes, your data rate goes through the roof. If you want to keep the picture quality.
Right, because you're breaking down the frame.
If you want to do ultra low latency and you want low data rate, your picture quality will pay the price.
Right.
But this is the first chip right now. Yes, it's proprietary. We make it, we use it, but it's fully compliant with H.265.
Okay.
Can you have the ULL HEVC over public networks or only private networks? It's a good question. The issue with public networks is that it's a big highway, and the antennas of the telcos, Verizon's, AT&T's, T-Mobile, those antennas are aimed at the bulk of users, and that you cannot have perfect control of the bandwidth allocation for your camera, even if you're willing to pay for it. It's called slicing. The provider, the company may decide, no, I prefer to have 10,000 people communicating over 5G than to have one broadcaster taking 50 megabits out of the highway. In a private network, you have control.
QoS.
You have QoS. Then right now, there's a lot of discussion now with the telephone companies to how to deploy this. But for the most part, this is tailored to private networks.
Are you going to do anything about the new compression system being able to handle high frame rate and HDR? I mean, what's happening with the bit depth?
Okay, this HEVC is 422 10-bit, no issue. And then the box that I show you, the ME80, I can use 4 1080p's to transmit one 4X camera. We've been asked to consider 6X. That means we have to steal 2 other 1080p's from the other chip. That's just something to think about.
But
Okay.
if you're ganging them that way, what are you doing it? Are you splitting the image up from the 4K, or are you?
I will not comment. The question whether we are splitting the chips and the images to achieve 6X or 8X, that to be discussed. Okay, another question, is the timing of the video effects guaranteed if you have a hybrid environment between the cloud? We've been heavily testing this, optimizing all of the transmissions between the cloud processing and the scalable, stackable switcher to bring down that latency between the elements to the minimum. And you know, the jury is the end user. If you're trying to do a chroma key between 2 segments in 2 different locations and it doesn't click, it's not going to be used for a major sporting event. And we are very confident. But there are many elements in the processing that we need to tweak to achieve that low latency. And we think we can achieve it. Is the virtual reality something commercially available, or is this a POC, a proof of concept? We've been doing demonstrations. We don't have a commercial plan yet. We're trying to find a business protocol to bring this into the market. But as you can see, it's very effective. But how to monetize it, how to give it a business framework is still in the works.
What kind of optical calibrations do you have to do for the VR applications and for the stadium, stadium signage things?
You can picture in your head the tracker that is connected to the camera flying around on the wire is going through the vibrations of the motor as it goes. Okay? And that tracker is communicating with the beacons that are surrounding in the stadium. And that communication is very exact. You're up and down a millimeter and affects the value of that metadata. And we had to do a lot of testing to compensate that. You cannot eliminate it.
No, but how do you calibrate the lens, the optical, the glass part of the equation, or are you just worried about position?
We didn't have those issues, to tell you the truth.
Because you had a lot of issues when the temperature changes and the lens performance changes.
You see, well, you couldn't see it in the graphics, but the camera is actually pointing to the stadium and to the people, and the graphics is is floating. And those graphics are calculated based on that position of the camera at that moment of transition. And that is the calculation of the graphic engine, not the lens. Anyway, how many 3D lots can you store 3D lots in the monitor for HDR application? As I mentioned, we can store up to 30 3D lots to do a high dynamic range to SCR. The back of the monitor has an output port. It's an enhanced output port that if you have, let's say, for cinema, you have a lookup table for graphics look, a look of the picture. You can bake that video coming into the monitor, apply the lock, and that baked output goes through the monitor at the back to feed a monitor wall, for example. Okay, this is a complicated one. You mentioned that Burano camera has a continuously variable neutral density filter. Is that the same type that we have in the studio camera? Very tricky, because the studio cameras are designed to operate in very harsh conditions, minus 30 degrees Fahrenheit. And the neutral density filter that we've had in handy cameras and now in cinema camera is a translucent LCD plane that is, the density is varied using electricity. That membrane, if you expose that membrane to the cold temperatures of the outside environment, it will break. It will just fragment. Then the neutral density filter in a studio camera is made of glass that rotates to create that continuous density. Completely different than the one we have in Burano.
One small question. The small encoder that you had was an MU2, I can't remember.
Yes.
Yeah. You talked about there was always a BNC input. Any thought to put like a multi-connector on that to have it like in the back of an ENG camera as a direct connection without a connect cable?
No. Right now, because remember, it can be used as a shoulder mount.
No, it's certainly flexible that way, but I'm thinking more to make it a part of something. Is that a plan at all?
Ultimately, you would like to see that embedded in the camera.
Yeah.
But right now, this first phase is just using a BNC, a small connector between the camera and the... All right, thank you very much.
Again, thank you. I want to mention that we have another meeting coming up pretty soon, about a month away. December 6th, it will be a Zoom meeting. The information will be emailed out, and it will be on NDI, Network Device Interface. Should be very interesting, a lot of questions on it. Hope you'll be with us. Thank you.